oxygen gas is added into the vessel, the pressure rises to 865 millimeter mercury. So apa yang berlaku? Bila saya nak ukur benda ni, I have the same container, I added in oxygen gas. Tapi saya tak tahu saya tambah banyak mana. But what I know, the pressure rises to this amount. So my question over here, the 865 millimeter mercury adalah pressure siapa dengan siapa?
Chlorine dengan oksigen.
Yes. This one is the addition between your chlorine gas and your oxygen gas. So dengan kata lain, that is actually our P total, the total between chlorine and oxygen gas. Assume all the gases do not react with each other, as we all agree yesterday, they tak boleh ada reaction. The temperature remain constant. Calculate the mass of oxygen gas added into the vessel. So we are looking for the oxygen gas in gram. Yang ni yang kita nak cari. Okay. So, soalan saya. Yang dah buat. Ada siapa yang dah cuba? Okay. Sabila buat guna cara apa?
I find the pressure of oxygen, and then I find the mole fraction of oxygen, and then I compare with I find the mole of chlorine gas also, and then I use the mole fraction formula, get the mole of O2 times the molar mass, I get the mass.
Sabila guna cara mole fraction, okay, mole fraction and partial pressure, and cara Sabila dia tak kira temperature. Anybody using ideal gas equation?
Saya, Miss.
Jawanis guna ideal gas equation. Jawanis, kalau macam tu, mass of oxygen that you calculated?
0.084.
Sama, Sabila?
Yes.
Okay. Alright, saya buat dua-dua cara. Saya nak tunjuk dua-dua cara. Saya nak tunjuk cara Sabila dulu, sebab Sabila cakap dulu kan. So, what is actually Sabila doing? Something very simple. When I have a question given like this, I think the quite obvious thing, the first thing that you can calculate quite obvious is the pressure of the oxygen. Betul? Kamu ada pressure of chlorine, kamu ada pressure of jumlah. So from that, you know that the pressure of the oxygen will be the P total minus the chlorine. I think this is the one that most obvious. Yang paling jelas. Kenapa paling jelas? Sebab saya nak cari pasal oxygen, saya nak semua benda pasal oxygen lah. Betul? So you have the millimeter mercury, if I'm not mistaken, 105 millimeter mercury. I keep it in millimeter mercury first. Okay? Dah selesai? Dah. And then the entire question giving you three things. The volume, the mass, and the pressure. So pressure kita dah selesai. Volume tak boleh buat apa lagi. Betul? So what do we do next is obviously changing the mass to number of mole. Kita akan tukar mass yang dia bagi kepada number of mole. Knowing that the number of mole chlorine is the mass of chlorine 1.35 over with the molar mass which is 35.5 times 2. If you read the question very carefully, the trick of the question adalah dia hanya kata chlorine gas, dia hanya kata oxygen gas, tapi dia tak bagi molecular formula. Okay? So you should know the moment you saw the word gas, you should know it's a Cl2. The moment you saw it's an oxygen gas, you should know it's an O2. That's why the molar mass times 2. Okay? Alright. Anis Nabila, can I have the number of mole, please?
0.019 mol.
Setuju yang lain? Okay, kalau tak setuju bagi tahu. So, what Sabila do when you get the number of mole and the partial pressure of everything? So, what we do is we find the mole fraction. I heard the word mole fraction. So, I will be, Sabila, finding the mole fraction of oxygen or chlorine?
Of oxygen.
Of oxygen. So, I use the mole fraction of oxygen, means I will be using the partial pressure of oxygen equals to the mole fraction of oxygen, all right, times P total. Because I keep everything in millimeter mercury, so I want to use the millimeter mercury, 105 equals to the mole fraction and the P total 865. So you got your mole fraction over here. First question to Sabila, did you use in millimeter mercury or you change it to ATM?
I use millimeter mercury since both same unit.
Okay. So anybody using ATM? Ada orang guna cara yang sama tapi guna ATM? Human, can I have the answer?
0.1214.
0.0, sorry,
1214.
0.1214. Is that the same with you, Sabila? Okay. And what I'm trying to show you over here adalah unit tak penting. Yang penting unit kena sama. Okay. So human kat sini tak payah tukar ATM pun tak apa. Okay. Sebab unit dia dah sama dari awal. Kita tak guna ideal gas equation. That's why kita boleh keep it in millimeter mercury. Okay. Very good. So you got the mole fraction of oxygen over here. And once you got the mole fraction of oxygen, we know that the mole fraction of oxygen is actually the number of mole of oxygen over the number of mole total. Right? And saya nak cari number of mole oxygen. But the problem, we don't have the number of mole total. So how can I find? How can I proceed, human? What do you do next?
Lepas tu saya cari mole fraction Cl2.
Kamu cari mole fraction Cl2. Human cari mole fraction Cl2 guna formula mole fraction ke?
Tak, yang satu tolak mole fraction SO.
Tolak je. Alright. Semalam benda yang kita buat ni. Okay. Even dalam subjektif pun benda ni kamu boleh buat. Bila kita nak cari mole fraction of Cl2, kamu tak payah cari balik mole fraction. Guna je satu tolak mole fraction oxygen. So kamu akan dapat terus kat situ. 1 minus 0.1214. So over here you got 0.8786. Betul? Okay. Thank you. So you got the mole fraction of your chlorine over there. Setuju? And why from the mole fraction of chlorine kita boleh dapat number of mole total? Sebab number of mole chlorine kita ada. So formula again, mole fraction of chlorine equals to the mole of chlorine, number of mole of chlorine over number of mole total. Mole fraction chlorine yang kita dah kira, baru kira tadi. Alright? Number of mole chlorine yang kita dah kira awal tadi, Anis bagi 0.019. So from that, you will then get the number of mole total. And the number of mole total yang kamu kira boleh masuk ke dalam ini. Right? Okay, nampak tak? So, you will then get the blah, blah, blah. Can I have the number of mole total, by the way? Anyone?
0.0216.
Okay, setuju? So from there, we can find the number of mole of oxygen gas by using the mole fraction of oxygen gas just now, where you already have both the mole fraction, 0.1214, and then you already have the number of mole total, 0.0216. So from that, you will then get the number of mole of oxygen. But do we stop at oxygen? Do we stop at number of mole? Question asking for mass. Yang ni saya tak payah tunjukkan. Okay. So mass of oxygen, gas. Cuma saya rasa one of the biggest trick yang saya cukup risau bila soalan tak bagi molecular formula dan kamu terlepas. Soalan ni bila keluar sebagai final exam, ramai sangat yang bahagi dengan 35.5, ramai sangat yang hanya darab dengan 16. But you should always know whenever it's a gas, there should be Cl2. Whenever it's a gas, it should be O2. I think we talk about that every single time when we come across this. Okay? So be careful with that, you get the mass of oxygen. Any problem? Senang cara ni? Alright? If you can think of this way, that means that you are good. I mean, you are good. You can use the formula of the Dalton's law, partial pressure and so on. Cara ni mungkin kamu tak sangat biasa sebab kamu baru jumpa formula ni first time. Dan kita ada cara lain nak buat. Okay, and I want to show you both because Zawan is using that. And what are we going to do next is, I just want to, dah semua dah. Okay, I just want to change it. We are going to calculate the same thing from the beginning. We are still calculating the number of mole of chlorine. I guess Zawan is betul tak? Alright. And then kamu akan guna satu formula yang sama tetapi dua kali. Cara Zawanis tak salah. Alright, mana-mana, dua-dua cara untuk saya senang. Dua-dua cara adalah betul, mana-mana yang masuk kepala otak kamu during exam. Okay? Zavanis is using ideal gas equation. Zavanis, ideal gas equation pertama, Zavanis kira untuk chlorine ke oksigen?
Saya kira klorin sebab saya nak dapat temperature.
Yes. Why we are using ideal gas equation? Because we have the partial pressure of chlorine, where we are, partial pressure of chlorine. We have the number of mole of chlorine. We have the volume of the container. Alright, we have everything except the temperature. So saya ada dua benda, satu benda yang dah complete, ada semua benda kecuali temperature yang saya boleh cari. Dan lepas saya jumpa temperature yang constant tersebut, saya boleh masuk ke dalam oksigen. Betul Zavanis? Alright, and both way is correct. So apa yang Zavanis buat is quite simple. PCl2, partial pressure chlorine, number of mole chlorine, RT over volume. Number of mole chlorine yang kamu kira 0.019. Your R, Zavanis guna apa?
Guna untuk ATM 0.08206.
Alright, 0.08206. Temperature is the one that we are looking for. Volume 0.5. Siapa yang guna formula ni, satu je isu as always. Unit. Formula ni senang. Kenapa saya kata formula ni senang? Dia lagi senang berbanding the mole fraction sebab kita akan buat exactly the same thing twice. Kita akan buat exactly the same thing twice. The only things different is unit. Kat sini, the extra work that I think Zavanis need to do is, I need to change all the value to ATM. Betul? Okay. So, what is the partial pressure of chlorine in ATM?
1.
Tenang, yang ni tak payah tanya, tak payah tekan apa pun boleh dapat. Betul? 760 mm mercury. Oksigen?
0.1382.
0.1382 ATM. This is the only extra work Zavanis kena buat. Okay? So make sure you take the value is the correct. Make sure it's in ATM because the R that Zavanis is using is 0.08206. Therefore, over here, cara ni, Zavanis tak payah bagi jawapan kat kawan kamu biar dia orang kira sendiri. So you'll be getting temperature in Kelvin. Dan temperature yang dapat tu, kamu boleh masuk terus kat sini, tetapi kat hari ni, kat formula kedua, we are not looking for the temperature. We are looking for the number of mole. Okay? Pressure dah ada. Zavanis dah tukarkan 1382 ATM. We are looking for the number of mole. Your R remain a constant 0.08206. Your temperature is the one that you calculated just now. Nampak? The reason, temperature remain constant. So macam biasa, you'll be getting your number of mole of oxygen over here. Then you change to mass. Okay? Tak ada siapa salah, tak ada siapa betul. Dua-dua cara yang you all buat, semua betul. And I show you both is, you know, to open up your mind, to see how your friend think and to see how you think. So in the question, it depends on what you want to answer. Okay? Alright, senang? And I guess everybody agree that the answer is 0.0839 just now. No matter is Sabila guna cara mole fraction tadi ataupun Zavanis guna formula ideal gas. Kamu tetap dapat jawapan yang sama. Betul? Okay. Satu je weh, bila tak dapat jawapan sama. Saya yakin, saya agak yakin tak dapat jawapan sama tu sebab salah tekan calculator je. Bukan tak boleh buat pun. Okay. Question. Cara mana senang? First or second? You all suka cara mana? First. Alright. Saya suka cara first sebab calculation dia pendek. Tapi saya rasa majority student bila dalam exam mungkin dia akan come across this method. Sebab ideal gas equation kamu lebih suka nak guna, kamu familiar dengan PV-nRT. Tapi sayang, PV-nRT unit. Okay, tu je tempat dia. Okay, so settle soalan 2. Happy with that? Tak ada soalan lain kan? Calculate mass of oxygen. Easy? So open up your minds and think of the other method of doing it. Soalan 8 tadi. Okay. Bukan soalan video kah? Alright, if you look at the video soalan yang saya bagi adalah ada dua jenis soalan. Soalan 8 dengan soalan 9 pun ada dalam video. Soalan antara yang favorite dalam exam. Okay, we are going to discuss both, don't worry. Okay, antara soalan favorite dalam exam. I think the most important thing in this question is you need to understand what is going on. Okay, I have two vessels, means I have two container. Alright, and these two container is connected by a valve. A valve means satu switch yang kamu boleh buka dan tutup. Okay, we are connected by a valve. A vessel A, that is my A. In the A, I have 1.5 liter neon. Okay, and the pressure of neon, obviously in there, I only have neon, therefore it's 0.395 ATM. Neon punya sahaja, tak ada orang lain. Settle soalan pertama. Okay. Sentence kedua, vessel B, that is my B. In the B, I have 2.5 liter argon. And the gas pressure at this. So the partial pressure of argon equals to 0.658 atm. Both vessels are kept at the temperature of 25 degrees Celsius. Bermakna kedua-dua akan duduk dalam suhu yang sama, 25 degrees Celsius, which is 298.15 Kelvin. Kita tak tahu nak guna ke tak. Saya tukar je. Okay. Zulaika, tengok apa tu? Duduk dua orang Fazlina duduk sekali kah? Okay. Apa tengok apa? Hampa duduk kat mana?
Duduk semalam. Dia tempat semalam ni. Kat sini je lain lagi.
Cakap dengan kawan jangan kacau. Sekejap aku tanya soalan. Pagi dia orang sekali mai, saya tanya soalan. Where we are? Temperature. Tak tahu nak guna ke tak, tapi tukar Kelvin. Okay? Calculate the mole fraction and the partial pressure of the two gases after the valve is open. The only things that trick you, this one. Alright? Tadi close valve. Sekarang valve is open. Itu je. So, dengan kata lain, semua yang saya bagi ke atas sekarang, okay, semua yang saya bagi ke atas sekarang, this is when the valve is closed. So right now, we want to move for the valve is open. And imagine this thing right now open. So saya buka switch tu, this thing right now is connected to each other. And since they are gas, bila saya buka switch tu, gas tu takkan duduk kotak A je lah. Betul? Kotak A dengan B akan campur. So the very first thing that come into your mind when the valve is open, ladies and gentlemen, volume change. Betul? Dua container, tutup blok kat tengah-tengah. Saya buka blok tu, so dua container tu bercampur. Therefore, the first thing that come into your mind should be the volume change. Alright? So, lepas saya buka, dia tak jadi 1.5 liter dengan 2.5 liter. Lepas saya buka, dia jadi 4 liter. Agree? And the question asking for, after the valve is open, the question asking for the partial pressure of argon, partial pressure of neon, mole fraction of argon, mole fraction of neon. Okay? So, nak senang, the trick of the question adalah, soalan tanya mole fraction dulu. Dia jahat. Dia sebenarnya senang adalah cari partial pressure dulu. Untuk soalan macam ni, untuk soalan ayat, alright, untuk soalan ayat, especially objektif, nanti bila dia minta kira dua benda, kamu tak semestinya kira ikut urutan. Kira mana yang senang nak dapat dulu. Okay, kira mana yang senang nak dapat dulu. It's objektif. Betul? So, kira mana yang senang nak dapat dulu. Dia bukan Roman 1, Roman 2, Roman 3. Tak payah ikut urutan. Kira apa yang kamu senang nak dapat. So, over here, it's actually much easier to get the partial pressure. Guys, temperature remain constant. Volume change. Yang tu benda. Next thing I want to ask. After the valve open, is the number of mole remain constant or the number of mole change? Kita buka tak tambah gas? Kita tak tambah gas dan kita tak keluarkan gas. Betul? So, in the other words, number of mole pun sama. Guys, temperature constant, number of mole constant, volume change, pressure also change. What laws apply? Anyone? Dia tak boleh anyone. Bila anyone tu tak ada, siapa nak buka mic? Tasha ni?
Boys law.
Boy's law. Alright. Just want to remind you kenapa soalan ni suka keluar, sebab dalam soalan yang sama saya boleh tanya Dalton's law, saya boleh tanya Boy's law. Okay? Dan yang penting soalan macam ni budak confused. Yang tu yang paling penting lah. Jahat gila aku. Pressure inversely with volume at constant temperature and number of mole. You should come across this in your mind. So, formula of Boy's law, you have your P1V1 equals to P2V2. As always, saya jadikan closed valve saya adalah 1. Saya jadikan open valve saya adalah 2. So, 1 saya for gas neon. For neon over here, my P1 before we open is 0.395, where the volume is 1.5. Selepas saya open, pressure is the one that I'm looking for, neon. Selepas kita buka, open neon. So the V2 over here is 4 liter. Agree? Okay. That is neon after we open. So you have your neon after you open the valve. You can do exactly the same thing untuk argon. Okay. Ataupun, you get the partial pressure. Can I know the partial pressure? Hampa kalau tak panggil nama memang. Najlah. 3 bulan weh. Kita dating 3 bulan. Aku tanya soalan tak ada siapa lagi nak buka mic jawab. Yang buka orangnya sama aja. Alright, Najlah?
Mole fraction NE lah.
Mole fraction neon. Bukan mole fraction, partial pressure neon.
Partial pressure. 0.1481.
0.1481 ATM. Okay, agree? My question. To find the argon, can I use the total and minus the argon? Can I use total? Yang ni total? Tak boleh. Why not?
Sebab masa tu close lagi kan.
The biggest thing about this question is you have an open valve and you have a closed valve. Sebab tu, if you look at the way that I separate my data, saya tunjuk kat kamu siapa closed valve, siapa open valve. Kalau kamu tengah kira untuk open, kamu tak boleh ambil apa-apa daripada close. Tak boleh compare, tak boleh tolak, tak boleh mole fraction, semua tak boleh. Mole fraction boleh sebab number of mole sama. Tapi tolak tambah semua tak boleh. Okay? So over here, the only way to recalculate, to find your argon over here, satu-satunya cara masih adalah guna P1V1, P2V2. Sama, 1 kita letakkan dia sebagai close. So argon when it's close, 0.658 ATM. Volume 2.5 liter, looking for the partial pressure of argon open. And over here, masih adalah 4 liter. Therefore, you get the partial pressure of argon open. Okay. Senang. Putri, can I have the partial pressure of argon when the valve is open?
0.4112.
0.4112. Okay. Agree, class? Senang. Nampak? Boy's law apply. And to find the mole fraction. Whenever soalan minta mole fraction, saya rasa ada banyak cara nak kira, of course. Cara yang kurang bijak yang saya malas nak tunjuk pun adalah dia bagi volume, alright, and then dia ada bagi volume of the gas, dia ada bagi pressure of the gas, kamu boleh guna PV equals to nRT. Okay, sebab dia ada suhu semua kan, volume ada, suhu ada, and so on. Boleh guna. Siapa yang guna PV nRT boleh guna. Tapi panjang gila tak gaban lah. Betul? Alright, we have a much easier way. Kita guna formula mole fraction terus. Sebab kita dah ada partial pressure, kita dah ada P total. P total tak ada lagi, kita nak cari sekarang. So P total when the valve is open. Look at the way that I write my value. I will show whether it's now open or not. So the total pressure after the valve is open, obviously 0.1481 plus 0.4112. That will be the total pressure when the valve is open. 0.5593 ATM. Betul? Alright, correct me if I'm wrong. Betul eh? So, cara yang paling senang adalah guna mole fraction where you will use the partial pressure of neon equals to the mole fraction of neon times with the total pressure. Okay. So, can I have the mole fraction of neon? Kita tunggu siapa nak buka mic.
0.2647.
0.2647. All right, TV will be not answering any question anymore today. Thank you. All right, next question. How can I find the mole fraction of argon? Same question.
Guna satu tolak tu.
Satu tolak mole fraction neon boleh. Guna formula partial pressure neon pun boleh. Okay, guna partial pressure neon pun boleh. Nampak? Saya tak bagi dah dua jawapan sebab satu tolak je kan. Hang tahu dah jawapannya. Kalau yang ni betul, bermakna jawapan hang sepatutnya betul lah. Okay, yang penting hasil tambah diorang kena sama dengan satu. Okay, boleh. Alright, this is what I call cara senang. But touch wood, katakanlah. Dalam exam nanti, hang tak terfikir langsung formula mole fraction ni. Alright, sebab the only thing that come into your mind adalah ideal gas. So, kamu boleh guna partial pressure neon sama dengan times with the volume equals to the number of mole of neon, RT. Boleh guna formula ni. Sebab partial pressure neon open dah ada. Volume bila dah open ada 4 liter. Okay. So yang ni yang kita nak cari. R constant. Dapatlah ha. Temperature is given 25 degrees Celsius. Nak cari guna formula ni pun boleh. Panjang gila tahap gaban. Dah cari formula ni pula. Lepas tu kamu kena cari number of mole untuk argon pula. Lepas tu kena cari number of mole total pula. Baru cara dapat mole fraction. Panjang. But touch wood in the exam. That is the only thing come. Buat je lah. Okay, buat je lah. Betul. Daripada tak dapat, baik buat panjang tapi dapat jawapan. So, saya tak nak restrict sangat. Of course, I will try to show you the simplest way ever. But if it doesn't cross your mind during the exam, sayang jangan bazir masa fikir cara pendek. Tu yang saya selalu pesan. Alright? Hi Anira, you have your friend over there wiping her mouth. Baru lepas makan Maggi kot. Thank you. Where we are? Are we done? Thank you. Anira, hang kena bagi tahu satu dunia hang tengah kelas dan kelas Miss Wong adalah record di mana hang buka webcam, di mana video ni akan naik kat YouTube. Your friend is going to be very famous later. Where we are? Done? Done? Okay? Senang? Menjawab soalan anda? Ada cara lain lagi yang saya tak terfikir? Kadang-kadang kamu pun jumpa cara yang saya tak jumpa. So, bagi tahulah. Alright, kalau cara kamu lain dengan saya tapi jawapan still sama, then you can let me know whether we can do it or not. Okay? Next question.
Soalan 9.
Lima kita dah bincang, 6 tak ada apa, 7 tak ada apa. Okay, soalan 9. Ni lah yang susah pun. Alright, another favorite question in the exam, another favorite question in your what do we call that? In your objective question or whatsoever. I think the biggest problem in this question adalah gas yang kita kumpul adalah mixture. Biasanya dalam water displacement method, soalan-soalan biasa yang kamu jumpa dalam water displacement method, kita collect satu jenis gas je. Gas dengan wap air. Betul. Tapi the problem over here is the gas that you have, the mixture of gas that you collect in here, alright? You have the water, and then you have your atmospheric pressure. Air was passed through water at a temperature. So suhu 50 degrees Celsius until 2 liter has been collected at a pressure. So pressure is 920 millimeter mercury. So that is our 920 millimeter mercury, your atmospheric pressure. Knowing that the pressure of the water vapor is 92. So pressure of the water vapor, 92 millimeter mercury. Calculate the mole fraction and the partial pressure of all components in the gas mixture collected. Soalan hanya minta gas mixture collected. So, the biggest problem arise is in this type of question, kamu kena ingat satu, bila dia adalah gas mixture, which mean I will have my water vapor, I will have my gas mixture. And in the question stated very clearly, your gas mixture is your oxygen gas and nitrogen gas. Again, soalan tak bagi formula. Dia tulis oksigen dengan nitrogen, tapi kamu patut tahu dia adalah O2 dengan N2. Dan yang paling senang, given to you, 21% of oxygen. Yang ni congak pun boleh dapat weh. 21% oxygen. So nitrogen berapa persen sayang? Hang tekan calculator, biar betul apa?
79.
79.
Kita di kat mana? Apa kira tak boleh lebih 10 kah? Kira lebih je 10 tak boleh guna jari, kena tekan calculator. Apa ni? Alright, percentage easy. Okay, easy. So, whenever you hear the word mixture, whenever you hear the words gas memang mixture je. Alright, gas memang mixture. So, whenever you hear the word mixture, you know kita ada campuran. And campuran tak semestinya 2. Campuran boleh lebih daripada 2. Okay, read the question. So, macam biasa, when you want to calculate the partial pressure and the mole fraction, I guess the first thing and the very, very first thing is to find the pressure of the mixture. So I have my PATM will be equals to the P of my mixture plus my water. Saya guna perkataan mixture sebab total saya ada 2 orang. Dia bukan gas sahaja. Sama ada guna total, sama ada guna mixture. Okay? So guna mixture senang lah, kita nampak terus campuran gas tu. The atmospheric pressure right now 920. Mixture is the one that we are looking for. Water is given 92. So kamu akan dapat the partial pressure of the mixture. Betul? Okay, which is still in millimeter mercury. Soalan tanya, again, the trick of the question kadang-kadang dia buat jahat kat kamu adalah dia tanya mole fraction dulu. Soalan saya, if this question is coming out, senang nak kira mole fraction ke senang nak kira partial pressure dulu? Kalau dari awal kamu ada semua adalah pressure.
Partial pressure.
Partial pressure.
Sebab semua yang kamu ada sayang is a pressure. Betul? Saya dah ada pressure kat tangan. Soalan tanya mole fraction dengan partial pressure dalam soalan yang sama. Tak ada Roman 1, tak ada Roman 2. Tak ada urutan soalan. Jawab je mana-mana pun. Okay? Yang senang sebenarnya, boleh nak jawab mole fraction dulu pun boleh. Panjang lagi lah solution kamu. Alright? Dia sebenarnya akan jadi lagi senang bila kamu cari partial pressure terlebih dahulu. And how do I find the partial pressure? No formula is needed. Because I already know that my mixture consists of 21% of oxygen. Nampak? So, kalau 21% dalam total mixture tu adalah oxygen, so nak cari partial pressure of oxygen, senang gila. 21% darab dengan the partial pressure of the mixture. Yang ni kena hati-hati. Tak boleh ambil atmospheric pressure, tak boleh ambil yang lain sebab atmospheric pressure ada kandungan air. Kat sini kita darab terus dengan 21% sebab 21% of that mixture adalah oxygen. So partial pressure kena berhati-hati kat sini. Okay. So the mixture, if I'm not mistaken, tak ada jawapan dah pula. 828. Okay. 828 mm mercury. Ada orang tukar ATM? Anyone changing to ATM? No. Bijak sikit lah. Pandai lah. Alright. Sebab selalu budak bila dah belajar idea gas, bila hampa dah belajar idea gas, semua benda nak tukar ATM. Aku pun tak faham. So, nak ajar, tak payah. Okay. Kira the 21%, you got the partial pressure of your water in millimeter mercury. Next question. Do I need to use the exact same method to find the nitrogen gas? No. Kita dah ada total. We know that the P mixture will be equals to the P of the oxygen plus the P of the nitrogen. Betul? Nampak? Of course, siapa yang kira 79% tu tak salah pun. Sama je. Alright? Just want to open up your mind. Your mixture right now is 828 millimeter mercury. And your oxygen, if I'm not mistaken, saya dapat 173.88. Betul? So you got your 173.88 as your partial pressure oxygen. Oh, easy, easy. Kalau objektif boleh buat? Senang. Kadang-kadang soalan panjang. Nampak susah. Nampak banyak kena buat. Hampa tak rasa ke soalan yang lagi panjang, yang step lagi banyak, soalan tu sebenarnya lagi senang? Alright? Soalan panjang means they give you everything you need. Lagi banyak soalan bagi, lagi tak payah banyak kamu fikir. The less the question gives, soalan lagi pendek, soalan bagi lagi kurang benda, lagi banyak kamu kena fikir. Soalan lagi panjang, they give you everything that you need, you only answer. Alright? That's it. Apa yang susah? So you got the partial pressure of nitrogen gas. Done. Separuh of the question. Next question asking for the mole fraction. Betul? So mole fraction kat sini, saya pun tak tahu kenapa dia tanya mole fraction. Mole fraction dia 0.21 lah kan? Right? Dia akan dapat balik percentage tu lah. Betul? So, yeah, ignore the mole fraction. Dia boleh tanya soalan lain lagi ni. Okay, dia boleh tanya soalan lagi. Boleh? Question? Okay. Be very careful because normally in the water displacement method, I know normally in here will be only your gas plus your water. Normally. Tapi hari ni kita tukar gas tu, kita tukar kepada mixture of gas. So when you have a mixture of gas, mean you will have gas A plus gas B. So you want to find the gas A plus gas B over there. Alright? That is the only thing make it different. Kita boleh collect campuran udara, campuran gas berbanding dengan satu. Okay? Question? No? Easy? Alright, back to the thing adalah kita tak payah tukar kepada ATM. Alright, I hope you realise that right now. Kadang-kadang conversion unit yang akan menyebabkan jawapan kamu salah sebab dari awal kamu salah convert unit. Okay? So, we will just go through it very quickly. Ada soalan lagi yang saya perlu bincang? Let's see, soalan 1 senang, soalan 3. Kita tengok yang ni sikit. 3. Soalan 4 senang. Soalan 5 kita dah bincang. Soalan 6 sama dengan soalan 4. Soalan 7. Okay, kita bincang, kita tengok sikit soalan 3. Tak bagi jawapan. Kita check cara saya dengan cara kamu betul tak? Alright, kita check cara tu betul tak sama-sama. Okay. So, just very quickly. A sample oxygen collected over water 20 degrees Celsius pressure 738 torr. So, I have a sample of oxygen gas. Saya tak tahu kamu. Saya tak tahu kamu suka lukis ke tak. Saya suka lukis. I cannot imagine. Oh well, I study last minute 99.99% throughout my life. I study last minute, but I score very, very well, by the way. Alright, if you cannot score well, you don't study last minute. Okay? I don't score really very well, but I do score well. Okay? Study last minute, tapi masa kelas saya dengar je cikgu saya cakap apa. At least kalau cikgu saya tanya soalan, saya jenis menjawab soalan lah. Kalau hampa, kalau saya tak panggil nama, kita tunggu sampai saya pencen pun tak ada siapa jawab soalan tu. Okay, I have oxygen gas. Okay, and then that is my atmospheric pressure settled. The volume of the oxygen gas calculate given 310 milliliter. Dah lukis. Okay. A, partial pressure of the oxygen given. Partial pressure of the water given, 17.5 torr dia bagi. What is the partial pressure of the oxygen? Senang lah, betul. So the P ATM will be equals to the P oxygen plus the P water. From here, kamu dapat partial pressure oxygen. Setuju? Soalan pertama, perlu tukar unit? Tak perlu. Kita kekal dalam torr. Kalau saya kekal dalam torr lah. Yang ni, settle sendiri. Soalan B. What would be the volume of the oxygen gas when dry at STP? So ni adalah dry dah. Yang kamu cari ni dah dry sebab dah tolak air. Okay, jangan ditipu oleh soalan. Dry bukan bermakna kita kena tolak mole fraction water or whatsoever, tak ada. Alright, dry is just this one. After you minus out from the water, that is the dry. Okay. So over here, STP, sekali lagi. I don't know how many thousand times I've been repeating about STP. Okay. Hizam, STP, temperature, pressure.
Pressure 1 atm, temperature 0 degree Celsius.
Setuju kelas? Alright, selesai. Next question. How do I answer this? Can I ask what do you use? What formula do you use? PV equals to nRT?
Combine.
Combine. Ada banyak cara. Cara pertama, kita tunjuk dulu cara pertama. Cara pertama yang kalau dalam otak kamu mind block gila-gila habis tak gaban. Okay? Use this method. Find the number of mole of oxygen. Cari yang ni. By using this. You have your pressure yang kamu dah kira. Volume 0.31. R is a constant. Temperature 293.15. Kamu akan dapat number of mole oxygen. Okay? Lepas tu kamu repeat guna formula ni sekali lagi. Exactly the same formula. The only things that you change is the condition. Alright, kat sini number of mole dah ada. So number of mole yang kamu cari kat sini, kamu bawa. Duduk kat sini. Sebab number of mole tak berubah, is the same gas. Right? The volume and the pressure change. The volume, the volume is the one that we are looking for. The pressure and the temperature change. 273.15, pressure 1 atm. Nampak? Boleh? Dua-dua cara boleh. Sebab kadang-kadang combined gas law, siapa yang buat combined gas law, well done. Sebab kadang-kadang combined gas law kamu tak terfikir. Okay? Kamu mungkin terfikir dengan ideal gas law and boleh guna. Tak ada masalah. Cari number of mole. Guna number of mole tu substitute balik dalam ideal gas equation. Tapi keadaan yang berbeza. Pressure dengan temperature change. Okay? Alright? Settle yang tu. And kalau siapa yang tak guna formula ni, you should be very smart enough to identify something. We are talking about the same gas. I don't know whether you remember or not last week. When we say about combined gas law, Boyle's law, Charles' law, Avogadro's law, we must be talking about the same gas. Remember? So we are talking about the same gas, oxygen. And the same gas right now having two sets of condition. 310 milliliter, 293.15 Kelvin. Tol tak bagi, pressure. Volume ada, Kelvin ada, pressure ada. Soalan bagi suhu lain, pressure lain, tanya volume lain. PVT. Nampak combined gas law? Alright. So you can use your combined gas law over here. You can use your PV11 over T1 equals to P2V2 over T2. Okay? But siapa yang guna combined gas law ataupun siapa yang guna ideal gas law pun ada satu issue. What is the issue over here? What is the problem?
Temperature unit.
Pressure.
Temperature unit saya dah tulis. Pressure unit. Betul? The pressure unit having two different units. The only things that make you confused. I mean, soalan nampak senang. We always treat you. Always remember. Alright? Always remember. Our job is to make you do calculus. And if you're not doing the calculus, if you're not falling into the trap, then you got A. If you fall into the trap, then you got B. If you fall badly into the trap, you got D. Alright? So, adalah tempat-tempat dia. So, that is your ATM, that is your TOR. Change either one. Tak semestinya kepada ATM sahaja. Boleh tukar TOR boleh tukar ATM kepada TOR. Alright? Nak senang, tukar je ATM kepada TOR. Pun tak ada masalah. 760. Tak payah bahagilah. Yang ni tak payah tekan kalkulator dapat terus. Betul? Alright? So, the only things that I want to insist over here, siapa yang guna ideal gas law boleh guna, tak ada masalah. Tapi siapa yang guna ideal gas law, boleh fikirkan balik kita sebenarnya boleh guna combined gas law. Okay? And when you decided to use combined gas law, the only thing I want you to look at your answer right now is the unit of the pressure that you put in. and you should be very good to go. Okay? And the volume, kalau kamu guna 310, then the volume final answer will be in milliliter. Kalau kamu guna liter, then the final answer will be in liter. So make sure unit kena sama. Oops. Unit kena sama. Alright? Temperature, no choice. Kelvin, as always. Boleh? Can I have the volume
Miss,
answer?
Okay.
Ya, ya Zawanis.
Tak, saya terfikir langsung nak guna.
Tak apa, tak terfikir pun tak apa. Guna idea guess dapat juga jawapan weh. Zawanis dapat apa? Volume
Kalau
Zawanis
saya
dapat
dapat 0.274 liter.
Chicken kata guna combine gas kan? Dapat sama Chicken?
Saya dapat 273.83. Sama.
Sama je. Sama je. Alright? Sebab tu saya keep on nak bagi tahu satu. Dia bila kadang-kadang bila soalan yang lebih daripada satu option, budak akan jenis fikir aku nak buat cara pendek. So hang dalam exam aku nak fikir cara pendek. Tu yang paling orang kata paling bodoh lah. Hang daripada hang bazir masa fikir buat cara pendek tu, baik hang buat je cara panjang hang dah dapat jawapan pun mungkin hang tak tentu lagi fikir cara pendek tu. Don't waste your time thinking for the method. Use any method that come into your mind. And during my class, I will teach you both method, as much method as I can, so that you open up your mind and you realize that, oh, I have combined gas law. Okay? And at the end of the day, if you want to use either gas, keep it, use it. Still dapat jawapan. Why not? Okay? Yang penting dapat jawapan. Okay? Oh, yang penting unit kena betul. Alright? When you're doing objective, you cannot afford to do even one mistake. You got no space for mistakes. Okay? No, not at all. Alright, not at all. Can I have the answer? Can I have the gram of oxygen collected? Ada yang tak boleh buat? Can I have the gram of oxygen collected?
Saya dapat 1.1968.
Human got 1.1968.
68.
Ada orang lain? Human got 1.1968. Betul?
1.1984.
1.1984. Wow, quite different. Quite different. Yang lain? Lagi? Baru ingatkan tak yang buat. Dah duduk macam ni dah. Sekali jawapan lain. Cerita yang berdua ni. Okay, kita tengok jawapan mana betul. Alright, assume 1 liter of oxygen gas is collected in a container at the pressure of this. Dalam soalan what we call water displacement method. Dalam soalan water displacement method, and like I said yesterday, I think the biggest problem is the pressure given to you is the pressure of the gas or the pressure of the atmospheric. I think that is the problem. Selalu bila dia keluar soalan water displacement method, budak akan confuse dengan pressure yang dia bagi. Okay, pressure ni pressure siapa? Assume you collect 1 liter of oxygen gas in a container. Saya collect 1 liter oxygen gas dalam container at a pressure. At a pressure means saya, during the collection, my pressure is 740. So the 740 is actually the atmospheric pressure. Okay, if you read the question carefully, that is actually the atmospheric pressure. That is the temperature of my surrounding. Both of this is my surrounding. Okay, itu adalah cara yang paling betul. Cara yang kurang betul, bukan kurang betul lah. Cara yang kalau kamu baca soalan tu 10 kali pun tak faham juga pressure tu apa. Sayang, tengok soalan bawah tu tanya apa. Kalau dia tanya pressure of gas, bermakna yang atas tu atmospheric lah. Kan? Soalan tanya pressure of the gas. Takkan dia bagi pressure of the oxygen gas. Right? Mesti atmospheric lah. Nampak? Okay? Bila kamu baca soalan, especially soalan objektif nanti, saya agak yakin soalan objektif takkan jadi satu sentence. Alright, kadang-kadang ayat pertama yang dia bagi kamu tak faham sangat. Apa benda dia merepek ni? Value ni siapa punya? You lost, you know. Alright, it happens, betul? Sambung baca. Baca soalan kat bawah, tengok dia tanya apa. Daripada benda yang dia tanya, sometimes you can decide already the value given is what. The question asking for the partial pressure of oxygen. Straight away, you know this is atmospheric. It won't be the oxygen. Okay? So be careful with that. All right? Be careful with that. So I have over here my container as always. Container buruk kita. I have over here partial pressure of water 32 millimeter mercury. Saya ada 1 liter of oxygen gas. Okay? The atmospheric pressure given, the PATM given, 740 millimeter mercury. Temperature given, 30 degrees Celsius. What would be the actual partial pressure, mole fraction of oxygen and the mass of oxygen? Cari oxygen, cari oxygen, cari mass oxygen. Senang je, semua benda nak cari oxygen punya. PATM equals to the P oxygen plus the P water. PATM given 74 millimeter mercury. Oxygen is the one that we are looking for. Water 32 millimeter mercury. Blah blah blah, dapat. Ni tak boleh buat, tak tahulah. Soalan ni tak keluar exam lah. Senang sangat. Jahat aku. Alright, next. Partial pressure oxygen yang kamu dah kira. Use the formula of mole fraction times with the P total. P total yang kita dah ada. So partial pressure oxygen yang kamu kira kat sini 708 millimeter mercury. Okay. 708 equals to the mole fraction of oxygen, the P total 740. So dapat mole fraction. Betul? Dah dapat mole fraction. Next, kita nak cari mass. Kamu cari mass macam mana?
Saya pakai PV and RT.
Okay, yang ni yang saya nak tanya, bincang sebenarnya. Chicken kata dia guna PV equals to nRT. Let's say option 1. When option 1 ada means kita ada option 2 lah. Chicken use PV equals to nRT using the partial pressure of oxygen, I guess. Volume of oxygen. Number of mole of oxygen, RT. Alright, chicken?
Lepas tu yang lepas tu guna yang boleh didapat jadi mass tu, pakai yang mass tu.
Okay, pakai yang mass terus. Even better sebab soalan nak mass. So apa yang Syikin buat? I think mass of oxygen gas over molar mass of oxygen gas RT. Betul? Even better. The only person that use this so far. Ramai yang guna PV and RT lepas tu dia tukar daripada situ. Sama je. Very well. So pressure kita dah ada tau. Saya isikan je lah. Saya tak kira Pressure, partial pressure of oxygen kita dah ada. Tak boleh, kena tukar ATM, sorry. Tukar ATM. Dapat berapa sayang? Tukar ATM?
0.9316.
93
16.
16. Hang pun guna cara ni lah. Hang pun guna cara ni lah.
Tak, saya pakai mass PV MR per RT.
Sama lah.
Saya ingat yang pakai PV.
Cheese. Alright. Volume 1. Mass is the one that we are looking for. Keep it. Alright. Molar mass 32. Hang ni, hang susun balik pun nak kira dengan aku. Temperature 30 to 273,303.15. Betul ke Syikin?
Betul.
Okay. So, kamu dapat, siapa yang guna formula ni boleh, tak ada masalah. Saya memang tak kira, saya bagi je. Make sure substitution kamu betul. Because at the end of the day, tekan calculator je. Okay? Ada orang guna cara lain? Tak ada dah. Anyone else? Tak ada. Semua orang tak guna cara lain. Kecewa aku. Anyone? Ni yang senang. Cuba fikir ada cara lain tak?
Kalau pakai cara
Cari
lain,
mall lah.
saya number of mole darab molar mass O2.
Oh.
Cara sama lah tu. Still guna ideal gas equation. Ni cara yang pendek. Cara yang panjang. Dan jangan buat lah. Just open up your mind a bit. Ke tak payah tahu dah semua setuju dengan cara ni. Cara satu lagi tu panjang. Tak payahlah. Okay. Semua guna cara ni. Boleh lah. Okay. Tak payahlah. Okay. So, I think yesterday I show you when are we using this fraction, when are we using this ideal gas. Sangat bergantung pada soalan. Okay, sangat-sangat bergantung pada soalan. Depends on soalan kamu nak apa and so on. Okay, bear that in mind when you're using your ideal gas equation. Just a very, very kind reminder over here. Make sure unit adalah betul. Okay, so when your pressure is in ATM, therefore your R should be in what? Temperature must always be in Kelvin. You should know that. Okay, something very simple. Boleh? Siapa yang tak buat derive macam Shikin atau Human susun balik tu, boleh buat guna cara ni, dapat number of mole and then baru tukar. Pun tak ada masalah. Sama je. Okay, sama je. Rasa tak nak derive, rasa susah, buat cara biasa. Tak ada masalah. Okay, masalah dunia masih adalah tekan calculator. Okay. Alright. Kalau tak ada apa, I think we can move on. Just very quickly. Ini saya bagi cara sahaja. Volume 3 liter mixture. Assume gas are not reacted. Calculate the total pressure. Total pressure senang. Number of mole of NO. Number of mole of NO2. Find number of mole total. Betul? Okay. Find number of mole total. Dah ada number of mole total. Dia nak total pressure. So you can use over here. P total equals to N total RT over V. Betul? Okay. Calculate the partial pressure exerted by each gas. Oh, senang. Sebab dah ada total pressure, dah ada number of mole. So using partial pressure of NO equals to the mole fraction of NO times with the P total yang kamu dah cari. Mole fraction adalah number of mole NO over number of mole NO plus number of mole NO2. Alright, standard. Dah dapat satu partial pressure. Partial pressure orang kedua. Tak payah kira cara ini dah. P total minus P NO. Are we on the same page? Great. Alright, very well. And then soalan 4 dengan soalan 6. Aku tak tahu kenapa soalan yang senang aku repeat 2 kali. There must be, I copy paste the question and I forgot to change it. Cheers. Soalan senang. Lagi senang tak payah ajar. Orang tak boleh buat ini, aku tak tahu lah. Orang tak boleh buat ini balik tadi kan. Okay. Question about Dalton's law. The Dalton's law concept is new. I know. But it's easy. Trust me. Okay. Dia panjang. And macam biasa dalam exam, buat betul-betul, jangan hanya tekan calculator. Okay. So, next, you tell me about this. Ideal gas, real gas. Like I say, we are going to discuss only 3 things. Okay, ideal gas, real gas, and then we are going to talk a bit about vapor pressure and boiling point. We are going to talk a bit about phase diagram. Okay, kita nak main point je. Nak detail explanation, pergi tengok video. Saya nak conclusion je kat sini. Ideal gas and real gas, first and foremost. All the question that we do. Okay, your Boyle's law, Charles law, Avogadro's law, ideal gas law, Dalton's law. Semua tu adalah based on ideal or real.
Ideal.
Semua adalah we assume they are ideal gas. Alright, assume all gas in your question as an ideal gas. Okay. Second, majority or most of the time, your gas will be actually in the real form. Ideal is like the Prince Charming that you want to have in your life, but he doesn't exist. So you assume that your boyfriend is a Prince Charming, but he doesn't exist, you know. All right. if you found a guy that is looking so good, that is so healthy and super rich and only loyal to you, there must be something wrong with that guy. All right? Figure that out. Okay? Human is one fine day, you come across a girl that is so good. All right? So good. No flaws at all. It's either you're dreaming or it's something wrong. So wrong. Okay? Just human being, we always have something. All right? The weaknesses make you unique. Okay? So, we are going to compare this. So, what makes them biggest different ada 4 benda je yang kamu kena ingat. What is the condition for ideal gas?
High temperature,
High temperature and
low
Low
pressure.
pressure.
thank you. Alright, very ideal. Suhu tinggi, gas bergerak laju. Alright, low pressure, sorry, tersalah. Sangat-sangat ideal. Kamu fikir pun kamu dah rasa seronok. Oh, my gas having a lot of energy. My gas move as what they should move. Alright, low pressure. Tak ada siapa tekan saya, tak ada siapa tarik saya. Kawasan saya cukup luas. I move as I wish. Alright, it sounds so ideal, betul? But in fact, it doesn't happen. So in fact, what is happening is we are not having high temperature all the time. There will be time where you are having low temperature. Betul? There will be time where your pressure is not low. Manusia, alright? Gas pun sama. Mesti akan ada masa di mana kamu ada tekanan yang tinggi. Alright? Then the reality hits you. Then you realize growing up is not fun. Welcome to adulthood. Okay? True or not? Okay? Yes. So, that is what happened. So, next thing that you need to know, the conclusion of this ideal and real, remember that we say your volume of the gas particle is negligible. Pernah dengar? Intermolecular forces in your ideal gas is negligible. So, what happened in the ideal gas adalah negligible. Negligible. Macam biasa dah malas nak tulis. Nak bagi conclusion je. So, negligible over here means the volume of the gas particles. We talked about this previously. Alright, negligible over here adalah intermolecular force of gas particles. Okay, tak ada. Alright, tak ada. Sangat-sangat ideal. You have a lot of money, you have a lot of freedom, you have nothing to do, you know, so ideal. Alright, my volume, my presence is not going to affect anybody. My volume of the gas occupied the volume of the container. Saya bergerak anywhere I want with no force of attraction. Saya boleh bergerak dengan laju ke mana-mana saya suka. But in fact, in reality, everything becomes significant. Alright? Your volume of the gas particle becomes significant. Okay? Your intermolecular forces of the gas particle become significant. Dia dah tak jadi negligible. Dia daripada tak ada orang tarik kamu sekarang, tiba-tiba semua orang duk tarik kamu. Daripada hang boleh bergerak laju tadi, tiba-tiba hang tak boleh bergerak laju. Because of the low temperature, your low kinetic energy. Betul? So what caused this thing to happen? Nak explain sekali je. Because I think I make a mess in your lecture that day. I don't know why. So let's do it again. I'm so sorry. Okay? So what happened when high temperature? Saya ada satu container. Saya ada gas. Katakan kita letak gas, tak payah banyak-banyak 5 biji dah. Okay, 5 biji. Okay, benar. So, ada gas 5 biji kat sini. So, the first thing, I have high temperature. So, all the time, you know, whenever temperature, we relate to kinetic energy. Suhu tinggi, kinetic energy tinggi. Betul? Alright? Suhu. Am I still in?
Yes.
Yes, you are.
Hang on, my laptop. Sorry, it just everything went blank. Okay, thank you. So, benda ni takkan ubah. Temperature, kinetic energy, movement. Okay, move fast. Agree? And then, when you have low pressure means the volume remain big. The volume of the container tinggi. So, I have a big volume of my gas to move around. Tak ada siapa tekan. Your container tak ada siapa pergi kecilkan dia. Tak ada tekanan. Okay, tak ada tekanan, my volume remain big. When your volume remain big in here, alright, when your volume is so huge, the container size remain, what happened? Far apart from each other. Betul? Dia akan duduk jauh lah sebab saya ada ruang. Dan bila saya duduk jauh, dengan both related, saya duduk jauh, saya ada tenaga yang tinggi, apa jadi? Saya bergerak jauh daripada kawan saya and my intermolecular forces become negligible. Betul? Alright? Other than that, bila you are far apart, your space also, empty spaces, sorry, bukan space, empty spaces. Your empty spaces increase. Ruang kamu jadi besar. At this moment, agree? Just imagine right now, both of them combine. When both of them combine is where you have this negligible condition. Why the volume of the gas particles will be negligible in this container? Because I have such a huge container. I have this entire container for my gas to move around. So when I have this big container with a high kinetic energy, moving very fast, and I will be able to sit very far apart from each other with a lot of empty spaces. Saya duduk jauh, saya ada banyak ruang kosong, saya bergerak laju, saya jadi apa? Saya jadi tak significant sebab saya duduk kat tempat yang kecil-kecil tu. And at the same time, the same thing. Saya bergerak jauh, saya bergerak laju, saya ada banyak tempat kosong, I can move very freely to whenever I want. Betul? Intermolecular forces jadi not significant. Dia pergerakan gas kamu dalam ideal gas macam seolah-olah tak ada siapa tarik dia. That is how fast you move. Alright, that is how ideal you want your freedom. Okay, that is in the ideal. Agree? Okay, but the biggest problem arise is when it does not behave ideally. When it's not behave ideally in your real gas, I try to draw a similar container as possible. Okay. So, in the real gas, when the temperature is very low, kinetic energy, 3 tu je. Kinetic energy decrease. I move very slow. Bila kamu dah start move very slow, kamu takkan duduk jauh merata. Kamu tak mampu nak duduk jauh merata sebab saya dah duduk sangat-sangat dekat. Alright, saya dah bergerak sangat-sangat slow. Saya akan jadi 5 orang ni akan duduk sangat dekat. Dia akan duduk kat satu kawasan yang lebih kurang sama sebab semua orang bergerak slow gila. Dan pada masa yang sama, kita bukan hanya low pressure, low temperature. Kita ada high pressure. Pada masa yang sama, I have a piston that I can push the piston down and I push my container down. Look at the volume. The volume decrease. Volume tadi besar ni. Sekarang volume jadi besar ni je. Tapi bilangan gas sama. Saya tetap ada 5 biji. Betul? So over here, you will become closer. Kenapa closer to each other? You become closer because your volume decrease. And when you are closer, the empty spaces become smaller. Kamu duduk makin dekat. Betul? So, bila kamu duduk makin dekat dan kamu bergerak sangat-sangat slow, when you sit very close to each other, when you move very, very slow, you will then have a very significant intermolecular force of attraction. Agree? Just imagine, saya bergerak lambat, saya duduk dekat, so saya macam tertarik lah, saya seolah-olah macam tertarik. Okay? Dan bila kamu dah duduk dekat, dan kamu macam tertarik, duduk pun slow, bergerak pun slow, kamu macam mengambil kawasan ruang ni dengan banyak. Sebab tu volume of the gas particle in that small container becomes significant. Okay, agree with that? That's it. Semua benda pasal ideal gas dengan real gas hanya adalah the two condition. What happened to your pressure and what happened to your temperature. And then the things that you want to discuss, everybody rasa ideal gas dengan real gas susah sangat. Padahal benda yang nak bincang ni je. Apa yang negligible, apa yang significant. That's it. Alright, tak ada benda lain. That's it. Okay? And, are we done? Are we okay? Alright. And then, what happened next is we want to go for the exact same thing over there. We want to go for the formula. So dalam formula adalah apa correction yang kita buat. Okay, what is the correction that we do? Let's see. So ideal gas equation, you have your PV equals to nRT. Oops, nRT. Your real gas, you have your P plus N square A square over V square. Betul ke? Saya tak ingat lah. Correct me if I'm wrong.
A tak ada square kan?
Tak ada square, tak ingat. Tu aku tanya. Macam tak
Jangan
ada.
marah Miss, takut.
Marah. Hang marah. Equals to nRT. Okay. Alright. Bincang one by one. Pressure. First and foremost, do you agree that your van der Waals coming from ideal gas? Okay, agree, yeah? So this P over here is your P ideal. This P over here is your P real. Okay? Tengok balik keadaan ideal gas dengan real gas kamu. Dalam ideal gas, the intermolecular force of attraction is very negligible. Tak ada intermolecular force of attraction. Bila tak ada intermolecular force of attraction, you move very fast. Move fast, move freely. Agree? Move fast, move freely. Not only that, guys, you have one more thing. You collide freely. Bila hang bergerak laju, satu lagi ada benda. Hang akan collide. Hang tak akan bergerak aja, sebab bear in mind, gas will move randomly, continuously. So bila hang move randomly, continuously, hang akan berlanggar tak berhenti. And bila kamu ada collision, you produce one thing. You produce pressure. And the pressure that we produce in ideal, of course, we call it pressure of the ideal gas. Agree? Okay. So dia berlanggar banyak bear that in mind. Move very fast and very freely, collide very much, you produce a high pressure. Ideal gas pressure tinggi. Setakat ni setuju? Kalau setuju, kita move on kepada real. What happened in the real? Intermolecular force of attraction becomes significant. Alright, particles kamu sekarang tertarik. Particles kamu semua sekarang tertarik. So bila diorang tertarik, what happened? You move slow. And not freely. Of course not freely. Penuh dengan orang kiri kanan duk tarik kamu. Hang nak bergerak sikit, pacik tu tarik kamu balik. Kamu nak bergerak sikit, pacik tu duk tarik balik. Hang tak dan nak langgar, pacik tu dah tarik balik. Betul? So what happen bila ada intermolecular forces? What happen bila ada daya tarikan? You will collide, but you will collide less over here. Kamu akan berlanggar, still akan berlanggar sebab hang still bergerak. Tapi hang akan berlanggar sangat-sangat kurang. So because you still collide, therefore you still produce pressure. But the pressure that you produce is much lower. And the pressure that you produce over here is the real pressure. And we agree, the pressure of the real decrease. Setakat ni, better? Okay, because collision is lower due to the intermolecular forces. Ada orang tarik kamu. Kamu tak dan nak langgar, orang dah tarik balik. So, kamu tak berlanggar sangat. Bila tak berlanggar sangat, tekanan kurang. And therefore, we agree on one thing, I guess. P ideal will be higher than P real. Betul? Okay. So, next thing that I want you to look at is this. Over here. Kalau pressure ni adalah pressure ideal, pressure dalam adalah pressure real, guys, this whole thing yang saya kuningkan ni, this whole thing should be equals to the pressure ideal. Sebab apa dia kena sama dengan pressure ideal? Sayang, dia datang daripada ideal gas. Betul? So we come to a conclusion from here. The P ideal, the P ideal must be equals to the P real plus with the N2A over V2. Kenapa kena tambah dengan something? Kita nak tambah balik apa yang dah berkurang tadi. Apa yang berkurang tadi? Apa yang menyebabkan tekanan real berkurang? If you remember, the only thing that I highlight, apa yang menyebabkan dia collide kurang? Intermolecular force of attraction. So what is this correction about? This correction is about intermolecular force of attraction. Siapa yang menyebabkan collision berkurang? Siapa yang menyebabkan tekanan berkurang? Intermolecular force of attraction. Sebab ada orang tarik dia. Okay? So, alright. So, the A over here is your intermolecular force of attraction constant. Alright? So, just imagine guys, A lagi tinggi. A tinggi bermakna daya tarikan tinggi. Betul? Kalau dia tarik lagi kuat, alright, dia tarik lagi kuat, dia bergerak lagi senang ke lagi susah? Susah lah. Betul? Kalau dia bergerak lagi susah, bermakna dia senang tak nak berlanggar? Taklah, lagilah susah nak berlanggar, betul? Tarik lagi kuat. Nak bergerak sikit pun kawan tu tarik balik. Nak bergerak sikit, kawan tu tarik balik. So, bila dia bergerak lagi susah, berlanggar lagi kurang, tekanan jadi lagi rendah. Betul? Tekanan jadi rendah. P real jadi jauh lagi rendah. Tetapi, correction kena jadi lagi tinggi. Nampak? Sebab daya tarikan saya lagi kuat. Nampak? So, the entire pressure correction over here is based on one thing. Intermolecular forces. And the intermolecular forces based on what? Based on the condition. The high pressure, high temperature, low pressure, low temperature, high pressure. Dua keadaan ni adalah orang yang menyebabkan kenapa intermolecular forces dia jadi kuat dan intermolecular forces dia jadi lemah di ideal dan real. Okay? Boleh? Alright. Next. Similar thing, but we are going to talk about the second correction. The second correction that we are going to talk about is about volume. Okay? Sama, masih adalah guna your ideal gas and your blah 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 van der Waals. So I have my ideal PV equals to nRT. I have my real P plus N square A over V square. Volume minus ND. Yang ni kita nak tengok. Okay. This one. Anybody can tell me what is ND?
Volume gas particle.
Volume of the gas particles. Alright. Just nak conteng sikit. Kalau tadi, in the real, gas akan memenuhi ruang. Tapi kalau dalam real, gas akan duduk dekat-dekat. Setuju? Okay. So, the first thing that come into your mind for your ideal is this volume is the volume of container. Dan kenapa saya kata volume of container? Because in ideal, look at here guys, volume of gas equals to volume of container in ideal. Setuju? Gas bergerak jauh memenuhi ruang. That's why in all our question like just now, vessels is 1.5 liter. Terus kita ambil the 1.5 liter is the volume of gas. Betul? Kenapa jadi macam tu? Because we know the gas will occupy the volume of the container. So volume of gas equals to volume of container. That's why saya kata kat sini adalah volume container. And bear that in mind, this formula will produce this. Betul? Okay. So, over here, I have this. Kita ada dua layer of container. I hope you realize that. One is I have this. Volume of the gas. Second, I have the volume of the container that is empty without the gas. Okay. Dan semua ini, alright, this whole thing is the green color bits. Alright. So, we are going to take the volume of the container. This one is the volume of the container. Okay. So the entire thing. So your volume, by the way, your volume of gas is not equals to the volume of container. Okay, kat sini eh. So why we minus? Because this entire thing is the volume of container. So this thing is the volume yang ada dalam NB. This is the volume of container. Tapi yang saya nak hanya yang mana hijau ini. So kita nak buat apa? Kita kena tolak lah. This entire thing need to minus out the NB. And the NB is this part. This is the NB. The volume that occupied by the gas. Alright? Gas molecule. Gas molecule. Gas particles. Okay? Molecular volume dia. So you need to minus out. That is the entire bits that we want, which is only the green color. Tapi dalam ni adalah volume of container. Volume container besar. Dan kita tahu volume container sekarang diganggu oleh volume of the gas. So kamu kena ambil volume of the container, tolak volume of the gas. Because they are not equal right now. Okay? And why they are sitting close to each other? The same reason. They are sitting close to each other because of the low temperature, high pressure. Bergerak lambat, low kinetic energy, duduk rapat, dan intermolecular forces jadi significant. So dia duduk jadi satu kumpulan besar lah. Alright? Nampak? So bila dia duduk satu kumpulan besar, dia akan mengambil ruang kawasan tu. Dan kita nak tolak kawasan yang dia duduk tu. Sebab tu kita nak tolak NB. Kita tak nak kawasan yang dia duduk tu. Okay? Nampak? Okay ke guys?
Miss, I still don't understand why are we taking the green area.
Why we are taking the green area? Because volume of container.
But the left one is like volume of container equals the volume of gas particle.
Mm-hmm.
And then, so the important one here is the volume of container, is it?
Because your real gas formula is coming from your ideal. See the pressure just now? If you look at the pressure just now, the pressure, I would say this entire thing, all right, this entire yellow thing must be equals back to the pressure of the ideal because it's coming from there. So the same thing applies to the volume. The volume is not needed to be the same because the volume cannot be the same right now. All right, why the volume cannot be the same? Because my gas molecule occupied that area I need to minus out. But this one is actually the volume of container. So I want to minus out, I want the volume of the container that has no gas occupied. Because your gas volume become very significant. I don't want the volume of gas. All right, I don't want the volume of gas. Okay. All right, better. All right, I don't want the volume of gas because the volume of gas particles right now in your ideal is significant. They are taking up a certain space and we want to minus out the space that they are taking. All right, we want to minus out the space yang dia duduk kat situ. I have only a one small place and then I have something, the gas is sitting there, so I want to remove that area. Okay, we don't want that area. All right, boleh? Lagi? Okay. So, that is about ideal gas and real gas. Macam saya cakap, dia takkan ada calculation. Tapi bila dia keluar objektif, kalau dia keluar objektif, guys, baca ayat ABCD tu betul-betul. And like I said just now in the lecture, bila dia soalan explanation, I think it will be a lot better for you to read the question, conteng dulu kat tepi. You should roughly know what you want. Whether the pressure should be high or the temperature should be low. Alright, whether the kinetic energy patut jadi apa kalau ideal gas. Kinetic energy patut jadi apa kalau real gas. Alright, conteng dulu kat tepi sebab jawapan kamu, everybody know, jawapan akan beza 2-3 perkataan je. Betul? Alright, bila hang baca increase, decrease, hang lost dah. Okay, hang lost dah. So, daripada hang lost baca jawapan, jangan baca jawapan dulu kalau soalan explanation. Conteng dulu kat tepi. Conteng guna simbol pun tak apa. High temperature. So, arrow naik, pressure kena tinggi. Conteng sikit-sikit. At least you know what you are looking for. The keyword is what. Then you choose the answer based on what you write. Okay? Alright? I think that is easier because saya risau bila dia soalan explanation keluar dalam objektif and you know, the sentence will never make it easy for you. Never. Okay? So, all the keywords that you need to know. Boleh? Okay? So please conteng kat tepi dulu. Jangan jawab. Jangan excited sangat nak pilih jawapan. Okay? Boleh? Simple. Alright? Very simple. You tell me this. What is vapor pressure?
Vapor pressure adalah pressure yang diproduce daripada vapor molecules bawah surface of liquid.
Bawah surface of liquid?
Atas, above.
Above. Okay. So, I have a container. I have a liquid. Atas liquid tu akan ada wap. Okay. This wap is what we call vapor. And remember just now we say vapor, your gas, they will move non-stop. They will move randomly. Betul? And when they move non-stop and randomly, they collide. When they collide, they produce pressure. So that pressure that produced is what we call vapor pressure. Pelanggaran yang menghasilkan tekanan disebabkan oleh pergerakan wap air. Wap air kamu bergerak, wap air kamu berlanggar, wap air kamu menghasilkan tekanan. That is what we call vapor pressure. Look at my drawing. What is missing?
Close container.
Closed container. Thank you. If you watch the video very carefully, I insist vapor pressure can only be measured when you are sitting in a closed container. Bayangkan kalau container kamu terbuka. Pernah masak Maggi? Tak guna air microwave? Guna periuk? Alright, air kamu akan lagi cepat mendidih dengan penutup atau tanpa penutup. Alright, dengan penutup. Betul. Alright. When you have the lid cover, you trap the vapor. Alright. Bila kamu ada penutup, wap air yang terhasil dalam tu duduk di bawah penutup dan juga di atas air. So you trap the vapor. Okay. And when you trap the vapor pressure will increase easier. Betul? Compared to kalau kamu masak air tanpa penutup tadi. Apa jadi pada wap air? Wap air duduk atas air macam tu. Tak bergerak. Dalam mimpi pun tak. Betul. Alright, wap air akan bergerak. So kalau kamu masak air terbuka, kenapa air tu lambat nak masak? Dia akan masak. Dia akan eventually masak. Alright, kenapa dia lambat masak? Sebab wap yang terhasil awal-awal tu akan digerakkan ke sekeliling. Alright, the water vapor will be moved around. So the water vapor that trap is lower. Agree? So it must be closed container. So pelanggaran ni adalah vapor pressure. Next, why boiling point is related to vapor pressure?
Because
Sebab
the temperature where the vapor pressure equals to atmospheric pressure.
Because the temperature at a point, alright, at a point where the point is our temperature lah, at that particular point yang kamu panggil boiling point, suhu pada titik tersebut, where your pressure of the vapor equals to the atmospheric pressure. Pernah tak guna cerik yang akan bunyi zaman dulu, zaman mak saya zaman dulu. Ada cerik yang kamu masak air and then it will have the bell sound, you know. Have you ever thought of where the bell sound come from? Vapor pressure. Kenapa bila kamu masak air, alright, guna cerik yang sama, tapi loceng tu hanya akan bunyi bila dia start masak. Dan mak kamu akan panggil lah, api tutup api, betul? Alright? Kenapa? Sebab dia akan ada loceng kat bawah ni, dekat-dekat dengan tempat yang kamu tuang air tu, ada kecil je dia letak loceng. Dan loceng tu ada kawasan yang terbuka dengan luar, dengan kawasan yang terbuka kat dalam. So sebelum air masak, dia akan experience atmospheric pressure. Okay? Atmospheric pressure lagi tinggi pada awal sebelum air masak. Atmospheric pressure lebih tinggi daripada tekanan kat dalam. So loceng tak bunyi lah, tertutup je lah. Betul? Dan bila kamu masak air, at one moment, the vapor that produced inside is much higher. When the vapor that produced inside is much higher, you will have a much higher vapor pressure. And when you have a much higher vapor pressure, dia akan boleh tolak, boleh lawan dengan atmospheric pressure. Dan dia bila boleh lawan dengan atmospheric pressure, dia akan tolak loceng tu dan berbunyi. Suddenly think like you are so smart, right? That's why, bila air kamu didih, the loceng akan bunyi because of the vapor pressure inside cerik kamu is more ataupun at least equal to the atmospheric pressure. That's why dia akan bunyi. Semua tu datang daripada, bunyi loceng tu datang daripada tekanan vapor yang pergi langgar loceng tu. That is where the vapor pressure come from. Okay? Pernah masak air guna Maggi, guna just normal things, and bila air tu masak, penutup periuk kamu akan ta. Betul? Alright? Kenapa dia takkan buka and then terpelanting terus? Sebab kata vapor pressure tinggi. Sebab bila dia dah sama dengan atmospheric duk tekan penutup tu. Bila atmospheric pressure duk tekan penutup, vapor pressure yang terhasil kat bawah penutup tu, alright, akan tekan. Akan lawan dia. Bila dia dah tinggi, time mendidih dia akan lawan atmospheric pressure. Dia terbuka. Sayang, bila terbuka, vapor terlepas. Atmospheric pressure tinggi balik. Periuk tutup balik. So, air masak lagi. Vapor terhasil lagi. Vapor tolak pula benda tu. Terbuka sekali lagi. So, wap air keluar, atmospheric pun tinggi balik. Nampak? Sebab tu, bila air kamu masak, periuk kamu takkan terpelanting terus. Sebab the moment dia buka sikit, wap air akan keluar. Wap air keluar, wap air pressure, your vapor pressure decrease. Betul? So, penutup periuk tu jatuh balik lah. Right? Okay? Yang tu senang sikit kau nampak. Yang ni bukan zaman kamu, I think. Yang tu duk ramai mengangguk sikit. Okay? So, yeah, that is your vapor pressure. Kenapa periuk, your whatever things, alright, yang kamu masak Maggi, kamu tutup. Kenapa penutup periuk kamu boleh terangkat masa air didih? Vapor pressure. Okay? And that point, that temperature is what we call boiling point. Okay? So boiling point is not only yang kamu belajar 100 degrees Celsius or whatsoever. Try to be smarter. Your boiling point is when your vapor pressure equal or more than your atmospheric pressure. Takkan more than. Equal je. Alright? When your vapor pressure equals to the atmospheric pressure. Boleh? That particular temperature. Okay? Next question. What will be the factor affecting your vapor pressure and boiling point? Anyone? Kecuali Shikin, kecuali Sabila, kecuali Human, kecuali Zavanis, kecuali TV. Anybody else in this class? Shikin.
Kalau Miss tak cakap kecuali, jadi saya nak jawab lah.
No, I know. Kita tunggu Shikin, kita tunggu.
Kesian kami kena ban.
I'm not. Just your friend will be very comfortable sitting under you guys. Kita tunggu. Tak cakap, saya tak jawab. Saya tak bincang. Tengok video sendiri. 10 second. Sorry, come again?
Intermolecular force of attraction.
Alright, the next person yang kena ban, touch sini. Intermolecular force of attraction. Yang lain, Dila, Anis, dua-dua Anis, Putri, Ong, Ani, Iyat. Yang tu kalau selagi saya tak panggil nama, they are like that person in our class. Alright? Nasib baik bila cakap thank you Miss Wong tu bersuara. The only time kamu buka mic dan bersuara. Alright? Benjin also. Benjin sometimes lah dia ikut mood dia. Dia nak jawab, dia jawab. Dia tak nak jawab, dia duduk macam tu. Dia macam biasa. Alright. Intermolecular force of attraction is very important. Alright? That will be very highly affecting it. So you have, by the way, the intermolecular force of attraction is in the liquid. So you have your liquid. Okay. Closed container, closed system. So the intermolecular forces that we are talking about is the one in your liquid. Just very quick and very simple. Bayangkan daya tarikan tinggi. Betul. Intermolecular forces sangat-sangat kuat. Very strong. My question is only one. Easy to overcome or hard to overcome? Anybody else except the band termasuk touch ini? Easy to break or hard to break? Saya bagi option dah ni, hampa pilih je. 50-50.
Hard.
Oh, hard to break. Thank you. Alright, hard to break, betul. Okay. When it's hard to break, bila benda tu susah nak dipecahkan. Next thing. Bila benda tu susah nak dipecahkan, you need more energy or less energy?
More energy.
More energy. On the next person. More energy. Okay? Betul. Benda tu susah nak buat. Daya tarikan kuat gila. Benda tu tertarik dengan kuat. Susah gila nak pecah. You need more energy. When you need more energy, benda tu susahlah nak buat. Kamu perlu boiling point yang lagi tinggi. Alright? Kenapa boiling point yang lagi tinggi? Sebab kamu perlu tenaga yang lagi banyak. Macam mana nak dapat tenaga yang banyak? Letaklah benda tu atas api lama sikit. Dapatlah tenaga banyak. Api itulah tenaga, betul? Alright? Lagi lama hang letak atas api tu, lagi banyak tenaga kamu dapat. So when you need more energy, boiling point increase. Okay? So when the intermolecular forces is very strong, it's very hard to break. When it's very hard to break, you need more energy to break. So your boiling point will be higher. So when the intermolecular forces of liquid is strong, your vapor pressure will decrease. Why vapor pressure will decrease? Because it's very, very hard to break. Therefore, less vapor produced. Susah nak lepas. Mana nak dapat uap air? Duduk je lah dalam air. Betul? So when the vapor pressure decrease, you need to increase it to achieve the boiling point. So the boiling point increase. So ada 3 benda. So tak boleh nak cerita terus guna directly proportional or inversely proportional, tak boleh. Alright? And the intermolecular forces of liquid kuat, vapor akan sikit terhasil. So bila vapor sikit terhasil, vapor pressure decrease. Bila vapor pressure decrease, kita perlu boiling point yang lebih tinggi. Kita perlu tenaga yang lagi banyak untuk naikkan vapor pressure tu. Agree? Okay, simple. Itu je. Alright, itu je. Alright, happy? So, Ong tak boleh jawab dah. And the list go on. Lagi susah. Lagi yang tak nak jawab, yang belakang lagi susah. Phase diagram. First question. What is the use of phase diagram? Tak jawab, tak makan lunch ya. First question, what is the use of phase diagram? Yang lain sabar saya. Alright, human jari duduk atas mic dah bang. Bahasa kamu, any of the language that I can understand. I think I cannot understand Tamil, the rest should be fine.
Plot of pressure versus
It's a
temperature.
plot of pressure versus temperature. Yes, that is phase diagram. What is the use of phase diagram?
To determine the states of the substance.
All right. Finally, I hear Benjin. The only thing that I can make sure you are not picture because the fan behind you is moving. If not, I thought you are putting a poster there for me. Thank God you're sitting under the fan. All right. Sarcastic. Miss Fong biar sarcastic tak pernah tak kat. Tuh. So sarcasm. Very high sarcasm. Sorry. Sorry boy. Okay. 2 benda. Kenapa nak belajar phase diagram? Betul. Okay. Why we are learning phase diagram is because we want to know my compound or my substance is at what phase during a particular temperature and pressure. And tadi Anis kata, phase diagram is a plot between pressure and temperature. Yes, because when the pressure and temperature change, your kinetic energy and the movement of your particle change. Bila kinetic energy and the movement of the particle change, the arrangement akan berubah. Saya boleh bergerak daripada gas jadi liquid. Kalau tiba-tiba suhu saya tinggi, suhu saya tinggi, kinetic energy saya tinggi. Betul? Sebab tu saya duduk jadi gas. Nampak? Okay. Alright. So, 2 phase diagram yang kita akan banyak belajar in your syllabus. Carbon dioxide and water. I want to draw first. Okay, before anything, I want to draw first. Saya tak guna slide yang cantik-cantik sebab, well, you need to learn how to draw, I guess. Okay, tengok gambar tak shock. So, kita belajar nak lukis lah. I have a phase diagram. I have my pressure, most likely in ATM. I have my temperature, I want to use degree Celsius. Kelvin pun boleh. Tapi pressure memang selalu kita guna ATM. Okay? For the carbon dioxide, normally we won't start at 0. So if you look at my curve, I will not touching the 0. 1 line, 2 line, and then the third line, this is the important line, this line must be a positive curve. Setuju? Okay. Since we are talking about phase diagram, ladies and gentlemen, I think the most important thing, the phase. Kita ada 3, we have our solid, okay, with our gas, we have our liquid. Some book will use the word vapor rather than gas. We accept that, it's fine. Vapor boleh, gas boleh, okay, any will do. Happy with the shape? Okay, next, for the water, can I know what makes the phase diagram of water and your carbon dioxide different? List yang tak boleh bersuara tu masih on ya?
Dia punya B tu lagi.
Dia punya
OB tu negative slope.
OB. Saya tak ada O dengan B kat sini. Sebab tu saya tak letak label. What slope? OB betul atas nota dan atas video. Tak ada. What slope is that? What is the name of that slope? Selain daripada OB.
Solid liquid dia.
Solid liquid. If you look at your water, my gas and my liquid over here, dua line curve ni sama. But the solid liquid curve is this one. Let me highlight that for you. My solid liquid curve is this one. And the solid liquid curve, Zulaika saya tadi, say that it must be negative. As negative as you can. It should be a straight line, by the way. Sorry. Alright, negative. Negative banyak mana, Miss Wong? Negative je lah, jadi dia bergerak ke kiri. Okay, negative. Masih sama, the area won't change. The area shall remain the same. Clear? Okay. The point and the line saya rasa agak senang. Which one is the melting, which one is the freezing? I think yang tu tahu kan? Kenapa line tu nama condensation and vaporization? Is that any problem with that? Yang tu saya tak ajar kat sini ya. Yang tu tengok saya nak bincang apa yang diorang beza dan kenapa diorang beza. Okay? So over here, I have the main difference between my carbon dioxide and water. The first one is like what Zulaika said. Agree everybody? I have my second differences. What is the second differences? Zulaika, you can rest.
1 ATM punya position.
Everybody is here actually. Alright, everybody is here actually. Good, Adila. 1 ATM and triple point position. So I want to look at the triple point first. Where is the triple point? Apa maksud triple point? Anybody? What is triple point?
Triple point to solid, liquid and gas equilibrium with each other.
Solid, liquid and gas exist equilibrium at the same time. So at the same time, it's the same pressure and temperature. And look at one place, one dot, that all your solid, liquid, gas gather. That is my triple point. Agree? Saya malas nak label dua kali, so saya label terus that is my X, that is my X. Dua-dua sama. Saya label terus my X is triple point. Okay? Agree? So, Adila sambung. Carbon dioxide tadi, you say about triple point and 1 ATM. For carbon dioxide, 1 ATM should be located at where?
Lower than triple point.
Lower than triple point. Agree? And that is the reason why we use ATM. So soalan final pernah keluar, saya tak pasti SDS atau SES. Dia bagi phase diagram dalam pressure tapi bukan ATM. Dia bagi dalam, saya tak pasti millimeter mercury of torque. Kalau dia bagi dalam millimeter mercury of torque, the 1 ATM position will then change to 760 millimeter mercury. Same thing. Okay? We still need that. Same thing. Saya ajar sebab saya takut objektif dia bagi pilihan jawapan phase diagram yang berbeza. So you need to be careful with the axis and the unit. Okay? Next. Yang ni tak payah next. Saya dah jawab lah. Kalau carbon dioxide, 1 ATM is lower than your triple point, then for the water, my 1 ATM should be higher. Alright? Dan ada orang tanya, higher by how much, lower by how much? Tak kisah. Janji higher, janji lower. Okay? No, kisah. Selalu lupa yang ni. Dalam video pun saya lupa saya. For the triple point in your H2O, when we say tak kisah, dia tak boleh lagi tinggi daripada my critical point. Ingat critical point? Nanti saya tanya apa dia. That is my critical point, my Y. That is my critical point, my Y. Betul? So your 1 ATM tak boleh lebih tinggi daripada critical point. If you have your critical point over here, so my 1 ATM should be roughly over here. So that it won't be crossing your critical point. Is that clear? Okay. Saya selalu lupa hal ni. Sebab saya dah tahu tapi budak selalu buat. Okay, tak boleh lebih critical point. By the way, your Y over there is critical point. Okay, critical point senang. Kita akan bincang benda tu last. Okay, so far happy? Two main differences between carbon dioxide and water. Okay. Next, of course, reason. Why 1 ATM position will need to determine ataupun will need to depend on the triple point. I don't know whether you realize or not, guys. Do you realize that after the critical point, after the triple point, anything after the triple point, baru liquid kamu wujud. Look at your triple point. Perasan tak? Kalau semua benda yang duduk di bawah triple point, liquid tak wujud. Hanya ada solid dengan gas. Kalau benda tu duduk di bawah triple point, kita hanya ada solid dengan gas. Do you realize that? Okay, first thing. So, after you realize that, why, my question, why 1 ATM in the carbon dioxide need to be lower than the triple point? Adila, you can rest. Anybody else? Jiha tadi pun dah jawab, you can rest. Kita tunggu.
CO2 can only have solid or gas at any temperature.
At any temperature. Ayat tu betul dah. Because CO2 only can have solid and gas at any temperature and tak habis ayat tu Betul dah, Anis? Tak habis ayat tu. Any temperature, sorry?
Does not melt at 1 ATM.
1 ATM, jangan lupa 1 ATM tu. Alright, jangan lupa 1 ATM tu. Position tu. I don't know whether you realize or not when your carbon dioxide in our daily life. Kenapa kita letak 1 ATM as our measurement? By the way, before anything, cara yang saya lukis kat depan, the 1 ATM, the triple point, the critical point label on top over here, this is the minimum drawing of a phase diagram. Okay? This is a minimum drawing of a phase diagram. Label critical point, label triple point, and then label 1 ATM. One more thing. Selalu lupa. Benda tu logik untuk saya. So, saya selalu lupa nak pesan. Bila kamu lukis, your critical point tak boleh lebih tinggi daripada solid liquid curve. Orang yang paling tinggi mesti adalah solid liquid curve. Nampak tak? Dia duduk paling tinggi. Alright, dia duduk paling tinggi. Critical point kamu tak boleh lagi tinggi daripada dia. Okay? So, sama juga. your solid liquid curve kena duduk paling tinggi, your critical point tak boleh duduk lagi tinggi daripada dia. Tu je syarat dia. Okay? Alright. So, in carbon dioxide in our daily life, if you realize your carbon dioxide at 1 atm, your CO2 solid is your dry ice. And then you have your CO2 gas as our normal gas, alright? As our normal gas. Have you ever come across CO2 liquid? No. Because CO2 can only form liquid after 5.2 atm. That is a super high pressure, by the way. Alright? Triple point akan menunjukkan di mana mulanya benda tu ada liquid. So carbon dioxide having only liquid after 5.2 atm. And at 1 atm, carbon dioxide don't have liquid. That's why the 1 atm for carbon dioxide must be sitting lower than your triple point. And you can see over here, when it's sitting lower than your triple point, dia hanya akan lalu pada solid, dia hanya akan lalu pada gas. Sebab tu 1 atm kena duduk di bawah triple point. And that is my anomalous behavior. Kenapa anomalous behavior adalah kedudukan 1 atm je? Sebab most of our substance boleh ada solid liquid gas pada 1 atm. Betul? Normally kita boleh ada solid liquid gas pada 1 atm. Tapi carbon dioxide takkan wujud liquid carbon dioxide ever. Alright, at 1 atm. Boleh? Alright. Ayat-ayat lengkap, settle sendirilah. Okay, saya rasa ayat yang paling-paling kamu perlu tahu adalah 1 atm carbon dioxide ada dry ice, ada gas. Carbon dioxide liquid does not exist. Okay. Settle. So, what would be the anomalous behavior in the phase diagram of water? What will you discuss? Oh, by the way, tak habis lagi. Just very quickly. Kalau 1 atm higher pula. Kalau 1 atm higher pula. Apa jadi? Alright, at 1 atm, your water solid adalah ice. Your water liquid adalah air minum kamu. Alright, air kamu. And then your water gas is your wap air. Ni dah ajar sampai macam ni, hang tak nampak lagi aku ketuk balang sampai penyek. Tak pernah saya ajar guna bahasa Melayu like this. Ever in my life. You have your solid, 1 atm. Kena ada liquid. Tak ada liquid, kita nak minum apa weh? Dia kena ada gas. Nampak? Gas. So that is your gas, that is your liquid, that is your solid. So at 1 atm, for water, your 1 atm must be higher than your triple point sebab dia wujud 3-3. Setuju? So benda normal lah, tak ada apa yang anomalous. Ada 3-3 ada lah, right? So what is the another thing that we need to discuss in water? What is the anomalous behavior? Anybody?
Solid water float on liquid water.
Alright, Benjin is hungry. That's why Benjin answered. Benjin stop answering. Because solid water is less dense than liquid water, okay? But that ayat yang Benjin cakap will be explained by looking at where. Benjin quiet. Yang lain duk tak sabar. Yang tak sabar tu tak sabar. Yang tak jawab tu still tak nak jawab juga kau. Nampak kawan-kawan? Perangai kawan hang tu. So we wait. I want to know why. Why Benjin said solid water less dense than liquid water? What is the proof? Sabar, Shikin, sabar. Come on. Mimi, Putri, Anira, Hizam, Aina, Khadija, Najla, Ani, you're missing today.
Negative slope.
Negative slope mana?
Solid liquid.
Negative slope of the solid liquid. And kenapa saya guna solid liquid tapi saya tak guna OB and whatsoever? Because we can label anything we want. Okay? So saya tak nak kamu duk ingat OB ke apa benda. Nanti dalam exam tak ada OB, cakap misong salah aja. Okay? Negative slope. Thank you. The negative slope over here, that will then answer why is a negative. Negative bermakna dia adalah abnormal. Kenapa tiba-tiba dia jadi negative? Because the solid water is less dense than your liquid water. That is the reason. Because most of the time, dia adalah positive slope. Kenapa kalau dia positive slope? Kalau dia positive slope, alright, represent over here one thing. The solid is more dense than liquid. And most of the thing, guys, most of our substance adalah solid akan tenggelam dalam liquid dia sendiri. Betul? Alright, most of the time. That is our normality. Tapi apa yang abnormal dalam air, apa yang kita nak bincang dalam the anomalous behavior of water is the negative slope. Alright, the negative slope represent the solid less dense than the liquid. That's why your ice float on top of the water. Nampak? Okay. Any questions so far? Senang kan? If you watch the video is extremely clear. Okay. And phase diagram akan jadi soalan favorite dalam topik 5. Sebab kamu tak belajar ke SPM. Alright. Kenapa liquid dengan solid, the proses saya tak bincang? Sebab kamu dah belajar kat form 5. Kat sini kita bincang lagi detail. We talk about kinetic energy, we talk about intermolecular forces. Tapi proses tu kamu dah pernah belajar. Alright? So saya bincang benda yang kamu tak belajar kat SPM dah. Sebab benda tu yang akan jadi selalu keluar. Okay? Alright? So, anything else about this? Nothing? The two main difference. My question. Yes?
Why
Yes.
when a substance is denser, the melting point is higher?
When the, come again?
When a substance is denser, the melting point is higher.
Well, of course, the solid is more dense because you are more compact. When you are more compact, you need more energy to melt it. Right? Why it become more, that will be something to do with the arrangement. If you remember the solid water that we learned in your topic 4, why water floats, right? Remember the open space, open structure, empty spaces in the water? All right, in the ice? That arrangement of the ice will cause the ice to be easily melt because of the open space, because of the empty spaces that you have. But when the solid is more dense than the liquid, why it can be more dense than the liquid? Because the arrangement of solid is extremely compact. When it's extremely compact and you want to melt the molecule, you want to lose everything in the solid to become liquid, it will take a lot more temperature. It will take a lot more energy. Okay? Sabila asked something very nice. The positive slope and the negative slope over here also represent something. Okay? The melting point and also the pressure, if I'm not mistaken. Where is my pen? All right, the positive slope and the negative slope. Over here, the melting point will be directly proportional with the pressure. Right? The higher the pressure, the higher the melting point. Over here, the negative slope, the melting point will be inversely proportional with the pressure. Okay? Pressure lagi tinggi, melting point lagi rendah di air. Tekanan lagi tinggi, melting point jadi lagi rendah di air. Okay? Tapi kalau slope dia positif, melting point adalah directly proportional dengan pressure. Pressure lagi tinggi, melting point lagi tinggi. By the way, why we are talking about melting point? Because it's changing from solid to liquid. We melt the solid. Okay? Lagi? Anything else? Nothing? There is one more thing that I want to teach, so I'll take extra 5 minutes. Just one last question to you before I'm the one that talking. What is critical point? What is critical point? I need one more thing. Salah padam. Tak padam yang water. What is critical point? Yang tak nak bersuara sungguh nampak? Alright, you won't stay long with me. Don't worry. Alright, tak ada siapa nak jawab, so saya tak bincang lah. The next thing that I want to discuss, one only. Benda ni tak ada dalam syllabus, tapi dia keluar tiap-tiap tahun. Dia keluar tiap-tiap tahun because you should already know it. And it apply only to the water. Take a quick look. 1 ATM crossing this point Okay, and crossing this point. Take a quick look. This point is between your solid and liquid. So bila dia between solid and liquid, like I said, that is your melting point. Okay, that is your melting point. And then this point is between your liquid to gas. So that is what we call boiling point. Okay, betul. Tapi what makes the 1 ATM boiling point and melting point different from other? The word normal. Kalau benda tu jatuh pada 1 ATM, that is what we call normal melting point. Kalau benda tu adalah 1 ATM, kita panggil dia normal boiling point. Kenapa perkataan normal? Guys, the entire line over there. Do you agree that the entire line, the entire curve over here is actually your melting curve? Betul? Kan? The entire curve tu melting curve, right? So kalau Miss Wong letak titik di mana-mana yang saya nak, contoh saya letak titik kat sini. Alright? That is also my melting point. Betul? That is also my melting point. But it's not a normal melting point. The moment you see a normal melting point or a normal boiling point, that means that is the point that drop at 1 ATM. Our normal boiling point and melting point. Okay? Benda ni tak ada dalam syllabus. Tapi dia keluar tiap-tiap tahun. Saya rasa sebab kamu patut belajar kat SPM. Tapi budak macam tak tahu. Alright? So kat sini semua adalah boiling point. Liquid jadi gas, boiling point. Liquid jadi gas, boiling point. Tapi apa beza point-point ni dengan 1 ATM? 1 ATM is what we call normal boiling point. Okay? So the word normal boiling point, normal melting point means dia jatuh pada 1 ATM. Dan nak tahu dia adalah proses apa? I always tell you guys to look at the face. Tengok fasa dia apa? Dia duduk antara fasa apa? Dia duduk antara solid dengan liquid. Melting, freezing. Oh, yang tu takkan tak tahu Yang tu benda kita belajar dari tahun 4. Saya rasa the moment kamu belajar sains, betul? Alright. So look at the face, then you know what is the name of the curve. Boleh? Yang tak jawab soalan hari ini masih hutang kat saya ya. Alright. Lagi kamu tak nak jawab, lagi kamu kena jawab. Lagi susah soalan saya. And thank you for those that open up your mind and start answering. Thank you. Any problem with face diagram? The video is a bit long because it's a brand new thing for you. So the video is extremely detailed. If you watch the video and you understand everything in the video, any face diagram question you can answer. Alright? The only thing that don't have in the video is the normal melting point and the normal boiling point because it's something you should already know. So whenever the word normal means it's dropped at 1 ATM. That's it. Okay? Any question? Nope. Nope. Alright, I think that's it. Next week. Next week, we'll be going into your topic 6. Tapi saya rasa Amali dah bincang sikit, betul? Topic 6 dia macam ni lah.